For section 2.3, number 27 through 32 are all done very similarly. I'm going to model number 27, which we can apply the same techniques to the rest of these problems. So in this problem, a jogger parks her car 80 meters directly across from a trail that is parallel to a parking lot. So that gives us this line of 80 meters. And we're given the acute angle beta, which is formed by the shortest distance to the trail, that's the 80 meters, and the path she took. So the path she took, she kind of cut across here, and that's the path she took. So our question is, A, find the distance that she jogged to the trail. So that is that red line. So A is the red line. So let's just worry about A for right now. So given our little triangle here, I'm going to pop that out, triangle out a little bit so we can see what's going on. We're looking for that red line. So that's our missing value. So X is the distance she jogged. Sorry, my handwriting's terrible. I'm going to start that again. Equals the distance she jogged to the trail. And that's the red line. So let me put this as red to link that up. So I'll do this one. Okay, so that's the distance she jogged. Okay, and we also are given beta and the 80. So if I'm looking at angle beta, the sides I have are the hypotenuse, which is the x, and the adjacent, which is the 80. What I don't have or use or want or anything to do with is, I guess we'll do green, that opposite side. So when I look at so, ka, and toa, anything with the o, the opposite, I'm not going to use those. That leaves me with cosine, and cosine of beta is the adjacent leg, which is that 80, over the hypotenuse, which is x. And remember, we're solving for x. So to get x by itself, first multiply x by both sides, and then divide by cosine. You can also jump from here to here if you're comfortable with that. Excuse me. Okay, so now I just need to plug in the beta. So that I get from number 27 here is 10. So for number 27, x equals 80 divided by cosine of 10. That's not an angle I have memorized, so I'm going to have to grab my calculator for that one. So this is the exact value, and that's the answer I would expect on a test with no calculator. And our estimated value is going to be 80 divided by cosine of 10, which gives me, what is my units here? Feet? Meters, sorry. So this should be meters too. And that's approximately 81.23 meters. And since it's a word problem, I would prefer the answer in a complete sentence. So that is something like the jogger jogged approximately 81.23 meters to get to the trail. So there's my answer for part A. And then part B we'll do in purple. So in part B, I want to say take that distance that she jogged, that 81.23, and the rate that she's going to find out how long it took. So that's where we use the D, distance equals rate times time. So we know R and we know D, and we need to solve for T. So I'm going to rewrite this equation. I'm going to divide both sides by R and then I'm just going to get that D over R equals T. I'm going to switch the order just to, because I like getting that single variable on the left. And D is the answer we found in part A, which is about 81.23. And R, they've given it to us in the question, which is 3 meters per second. And that's meters. So the meters cancel, and I'm going to be left with just seconds. So I get time equals that distance that we had, should do equals approximately, divide that by 3, and I get about 27 seconds. Just as a side note, I'd also like to show you how that units worked out. So we have the meters divided by meters per second. So division is flip the second and multiply, and that's how you can see that the meters will actually cancel out, and I'm left with just seconds, which gives me the time. Okay, so that is B. So she took approximately 27 seconds.